All right, we're going to start our first chapter in this class, and this first chapter has a whole bunch of basic math concepts, things you probably haven't seen in a long time, maybe back in grade school, where we're going to talk about the foundations. Some of you might have a solid foundation of these ideas, and some of you might be a little bit shaky, but it's really important that we understand these basic concepts because they are the foundation for everything that we're going to see in this class. For example, fractions, adding, subtracting, multiplying, dividing, some exponent things, and some order of operations we'll cover in this chapter. During these videos, I will probably be working a little bit more quickly than you can kind of follow along. So you will probably have to pause. You may even have to rewind and re-watch some of the videos. But what's nice about these videos is that you can go at your own pace. So please take your time. I would like you to try some of the examples before I even do it to make sure that you understand as we're going through, and let me know if you need anything throughout, okay? All right, we're going to start in our first section of chapter 1. We're going to start at section 1.3 and start talking about fractions. In a fraction, we have what we call a numerator and a denominator. The top number is what we call our numerator, and the bottom number is what we call our denominator. So this fraction 2/3, our numerator would be 2, and our denominator would be 3. What a fraction is just simply a division problem, okay? So that division bar, that fraction bar is the same thing as a division. Okay, we're going to start first in this section by talking about factors and factorization. So to factor a number, we express it as a product, that's multiplication, of two or more numbers, okay? And writing these factors is important when we start to do things with fractions like adding and subtracting, where we might need to get a common denominator. So finding their factors might help us get that common denominator. So in example 1, it asks us to list all of the factors of 18. And so factors mean what two numbers multiply together to give us 18. So why don't you try to pause the video and see if you can come up with all the different factors of 18. What two numbers multiply together to give you 18? I came up with 1 and 18. 1 times 18 is 18. 2 and 9. 2 times 9 is 18. And I also came up with 3 and 6. 3 times 6 is 18. I think those are the only other numbers that multiply to 18. So our factors would be 1, 2, 3, 6, 9, and 18. Those are all of the factors of 18. All right, a prime number is a natural number that has exactly two different factors. So there's only two numbers that multiply to come up to that number, is that number and 1. For example, 2 is a prime number because the only numbers that multiply to 2 are 2 and 1. 3 is a prime number. 1 times 3 is 3. Those are the only factors of 3. What's the next prime number that you can think of? How about 5? 1 times 5 is 5. How about 7? 11? 13? 17? How about 19? And 23 are the first several prime numbers. Out of those numbers, there are only two factors of all of those numbers are 1 and itself. We call those prime numbers. So prime numbers are important because it's going to help us break down our values into prime numbers, numbers that only are divisible by itself and 1. So in example number 2, it asks us to label each of these numbers as prime, composite, which is a number other than 1 that's not prime, or neither. So we have prime, composite, or neither. So the number 29, do you think that's a prime number? Do you think that's a composite? Or do you think that's neither? Try to think of all the factors of 29. I can't think of any other factors besides 29 and 1, so I think this one is prime. What about the number 4? Can you think of factors of 4? Well, I know that numbers that multiply to 4 are 1 and 4, and I also know that 2 and 2 multiply to 4. So this one is called a composite. It's not a prime number. It has multiple factors. What about the number 1? Kind of a tricky one. We call this neither. 1 is kind of in its own category. We don't technically call 1 a prime number because it is 1 and there's no other numbers that multiply or factor to it. So we call that one actually neither. So every composite number can be factored into a product of prime numbers called prime factorization. For example, when we take that 4, we can break it down into a bunch of different prime numbers. Okay, let's practice one of those. In example number 3, it says find the prime factorization of 36. There's lots of different factors of 36, right? 1 and 36, 6 and 6, lots of factors of 36. But what we want to do, instead of writing down all of the different factors, we want to factor it into just the prime factors, prime numbers that multiply to give us 36. So as soon as I see that my number is an even number, I know that 2 can divide into 36. So I can take 36 and I can break it down into 2 and 18, kind of like a factor tree if you've seen this before. 2 is a prime number, right? The factors of 2 are only 1 and itself. But 18 can be broken down even more. I notice that 18 is also an even number, so I know 2 can divide into it. So 18 can be broken down into 2 and 9. And then 9 can be broken down one more time into prime numbers of 3 times 3. So we could say that the prime factorization of 36 are all of the different prime numbers that multiply to give us 36. That is 2 times 2 times 3 times 3. All the prime numbers that multiply to give us 36. So you could do a tree diagram, like a factor tree. Or some of you might want to organize yourselves a little bit better so you don't get confused. And I do something that kind of looks like an upside down division. I'm going to start with 36 and I'm going to divide 2 into it. 2 goes into 36 18 times. And then I know 18 is even, so I'm going to divide 2 into it and I get 9. And then I know that 9, factors of 9 are 3 and 3. And so then I can easily, more organized way of seeing it is I can see all 4 of these outside numbers are my prime factors, 2 times 2 times 3 times 3. It just makes it a little more organized so you don't have a bunch of trees going on and you don't accidentally look at the 18 and the 9 and you include those. So just two different techniques of doing a prime factorization, but making sure that you can break down these composite numbers into a bunch of prime factors so that later on when we do our common denominators, you understand how to get a common denominator more efficiently.